Welcome everybody to our fourth episode, Dr. Timmy's Robotics Queen. And today we would like to talk about skills needed to be a robotics engineer. And spoiler, it doesn't have to be only coding. We'll talk about that in a minute. So yeah, when I was studying robotics or robotic engineering, I thought the success was really simple. I just need to learn coding and build some robots, and then I can easily change the world. And interesting enough is that whenever I say I studied robotics engineering, people think I build robots. So the only possibility in their mind is you build robots and yeah, they do something just based on the building. So nobody really knows that you need to program them. At least that was my experience. And yeah, nobody really actually mentions debugging or working night shifts or solving problems or even communicating with others in order to understand the problem and to automate it. So yeah, when I say what was your feeling?
Well,
How a
when
robotics engineer?
I started, well, I didn't. My engineer was not in robotics, unfortunately. It was in manufacturing, but like in my mind before I started, because my dream was like really program. I thought like, yeah, I just need to learn programming, and I thought there was just one way. Like that's how you program a robot. Everyone is doing the same way. Um, because we're learning, and until I troubleshoot the first robot, because when you're writing brand new robot your first time, everything is clean, you're writing as you learn. So I presume everyone was doing the same way, because I thought everyone would learn the same way. So then I opened an old code to troubleshoot, and it was like, what is this? It's like that doesn't follow the rules I just learned. And
Mhm.
then I remember my supervisor saying, "No, Vanessa, like you have other ways. Like, and everybody writes different ways. Like you might be similar if you learn with the same, teacher, but it's different." It's like, really? For me, it was so blow my mind, because it's like, no, I thought everyone doing the same thing. So I was like, okay, now I need to understand even more programming, because I don't need to just understand the programming, but also the logic that somebody else created to make work.
Yeah.
Because the robots are great. Like you can write anything and they will pick and place. Could be like the terrible program you haven't seen, the robot will work. Might not be efficient, it might, lose a brake or a axis or whatever, but the robot will work. And for me it was okay, so I need a little more here. And when I started, my first job in automation was in a system integrator, and in my mind I was just going to program the robots. No, I have to learn. Everything was amazing. I learned how to program PLCs, HMIs, sensors, work with conveyors, and servo motors. For me was like something really, I didn't even imagine that back then. So yeah, like I thought probably was 5% of I need to learn. That's what I thought I have to. So it was interesting.
Yeah, interesting enough. So myth number one is you need to be the best programmer to be a robotics engineer. No,
Absolutely
totally
not.
not
No,
true. Yeah.
no.
So yeah, people often think that the best programmers automatically become the best engineers or robotics engineers, but you see, that's not the case. So we have seen something different in our careers. And yeah, so you don't necessarily need to be a brilliant coder to solve the
No.
problems and to work with people, because that's actually um, one of our main skills, I would say. So skill number one is actually problem solving, right?
Yes,
So
yes. Because you need
um,
to see, like solve the problem really quick, and
yeah,
that's every single day.
it's it's like basically detective work every day. A sensor doesn't work, you need to search for it, or the camera doesn't suddenly see anything, or the PLC doesn't work, or the robot doesn't move, and you need
Yeah.
to search for the problem. And after 20 minutes, you get to the place that you see, okay, the robot was just waiting for a sensor signal. Or the power was off. That's all.
Yeah, no, like
Emergency stop.
like we feel like you need to know everything, but even though the time I thought I knew a lot, and now I know myself that even now I don't know probably 30% that I what is out there.
Yeah.
But it was a time that I feel like, oh yeah, now I know enough. It was back when I just opened my business, and I was in this project and it was a brand new robot, and it was like, yeah, no, like I program new robots a lot, and usually most problems happen with troubleshooting old robots. Not when I say old, is not in the meaning of really 10, 20 years. It's just that somebody else programmed that robot.
Yeah.
Usually problems happen on that case. So I got this new robot. It's like, yeah, just power it on and calibrate, and here we go. So I powered on, and a lot of messages pop up. I was like, that's not possible. It's just the first time I powered on. Like, what's going on? I didn't have the chance to get a backup because it wouldn't fully
Yeah.
load. And I spent all like the knowledge I thought I had. It was like, oh, like I never seen that message before. I call the technician from the brand, that by the way, that it was in Ireland, so he was also my teacher when I was got trained on that brand a few years before. And he's like, Vanessa, I never seen this before. I had I'm working service for, I don't know, 3 or 4 years. This message is not out of the blue. Anyway, we spend 4 hours
Oh.
back and forth, not on the phone all the time, but like both. Like I working there with my laptop, internet, trying everything that you possibly can. He on the other side trying with another technician, at his office, because he also had the robot trying to uh, perform, trying to get the same error again to see, because we couldn't even find the manual. Anyway, someone that was, I think, I don't know, it was a client or someone walked in while we were talking on the phone and just told him in the phone, have you checked the cables? I was like, what do you
Classic.
mean cables? Because in my mind and his mind, if the cable was not placed well, would not even power it on. Like that's
Yeah.
what we thought. Like that's how naive we thought
Yeah.
we knew something. And then I swear to God, was the cable, not the power cable, the data cable that connect the robot to the
Communication.
controller, and has a lot of pins. So
Yeah.
someone, instead of connect properly, because it's a Pocoyoco system, it's just one way, he forced another way, so one of the pins kind of bent. I
Ah.
swear to God, was like, oh yeah, that's so simple. Yeah, but never happened before.
Yeah. And you don't think about
And
it.
yeah, and then I was like, how you think you know? And it's like something would happen. But that is the problem solving. You just need to try and try and try and try again, because anything can happen. And for me, it's just like, it's this cues that I, to that point, I just like told myself there is no way in a point in our professional life that we can say we know everything, because
No.
we don't. Like the technicians on the other side, and I don't know who told them, if it was an old mechanic from the team, was a really old guy in the team that came along and was like, have you tried this and that? And it's like, no, you try everything, because we thought was the software side. And he was right, it was the cable, but it never happened before. There was no message on the manual.
Yeah.
Anyway, but it's a skill. It, I say, in robotics is not something. It's like, yeah, you do this and that and you're ready for life. Like, no,
Yeah.
you need to be not good but comfortable in solving problems, because
Mm.
it's gonna happen every day, and
Yeah.
it's gonna happen different from yesterday and the day before.
Yeah.
And if like happen like a few times, that is like, yeah, every time you power on the robots, you need to check this and that. oh yeah, I programmed this type before, and then you go to program another robot, and it's not exactly the same anymore. It's like always something different. So yeah, the skills you think you know or you should know, it might be just 10%.
Yeah, I sometimes joke that robotics is only 20% programming and
Yeah.
80% asking, why did it work yesterday?
Yeah.
Why did...
Make notes. I used to, well, I still have like a notebook back then, like what was going wrong, and like what we how we fix it. And well, when I was working in the company before I opened mine, everyone was using as a bible. It was like, Vanessa, like, did it happen before? I was like, let me check. It's like, yeah,
Yeah,
it happened here when we installed that software. You have to delete this on your laptop, or would not install. Or it's like, yeah, that version doesn't work well, you need to work with the one before. Because I start making notes,
that's very good. Yeah.
because sometimes it would happen again, especially with softwares that we have to install every time you start a new robot. um but sometimes, like troubleshooting, like the cable there was like, yeah, make a note now, like every time I
Yeah.
see a message that I done doesn't recognize, I'm gonna check the cable.
Check the cables. Yeah. So skill number two, documentation.
Yes. Yeah, document not everything, not just what worked, but what
But
didn't work.
what didn't work? Yeah. That's that's even more
That's
important.
Yeah, I
And
remember like that job because of my notebook. I created I believe it was an Excel file. I don't know if they still using the company, but like we were like four programmers. So like the intentions, like we populate there, like was a arrow. We described the message, and then every solution we tried
yeah.
there and what worked. So then if it happened again, someone could just check, okay, they tried this, they already tried that. This is the what worked. And then if they try again in another situation and that solution that worked didn't, they would also populate. It was great, but like I did that probably my last year, so it was like 6 months, but it was amazing. And that fire, I don't know if they keep going, but is one of the best things when you're working in a team, like a big team. If you're just yourself, just do for yourself, but do it. Because like you work in a project, usually it's like 6 months in the same robot. So you're gonna take like 6 months a year to maybe get another robot, another project, and you might forget everything that's happened in the beginning and might happen again.
Hmm.
So documentation, I would say, is very important.
Yeah.
Yeah, not just to explain to others what you have done, and like, oh yeah, the code is about pick and place, blah blah blah, but about testing, the testing phase, what worked and what not didn't work, because you can improve yourself and make
Actually, that leads to the third skill, communication, right? Communication is massively underrated because if you just say the robot doesn't work or the robot didn't work or didn't move, it's actually about as useful as saying I one of my body parts hurts.
yeah. Which one?
Saying at the doctor, or my car makes some strange noises. So
Yeah.
good engineers describe problems, right? They describe them, they isolate them, they help others understand them.
Yeah, describe like what happened, maybe if you don't know, like when happened, like yeah, it happened every time we change over, or it happened every time it plays the part, or
Yeah,
it picked the part, something. Yeah, the communication. And I remember when working in projects, especially when you're building the machine, not when you're troubleshooting, but like when you're building a machine, when you're testing, I would say communication should be a key. And I used to say that a lot, the company I used to work, because sometimes we work in different shifts, or like the design team would stay longer and change something. So we would get in the
just
morning
one
and,
little tiny thing.
oh yeah, just like we were running the machine yesterday. I mean, it was not working perfect because we are testing, but still pick and place something. And today it's like, is not pick and place anymore. It's placing all, because one thing I learned, don't know if you agree or not, that was my supervisor. He was great. If the robot is placed wrong, it's because it picked wrong. If the robot doesn't place wrong, it's just that is the reason is one is
Yeah,
speaking.
yeah,
And we used to say that a lot. It's like if you see the robot place wrong, just go for the picking area. And I was
mhm.
like, no, but we did yesterday. We just need to increase the speed. Was picking in place, was missing like 1 in 5. So, I mean, was working ish. And now today it was missing all 5. It was not even pick one. And we was like, no, we try again and try again. We anyway 2 hours in, because the design team, as it they stay longer, they didn't arrive with us, they arrived a
Yeah,
little bit late. They got around us like, hi guys, it's working. Like, what do you mean it's working? Like, did you change anything? Oh yeah, we changed the sensors because the client asked a different type of sensors, blah blah blah. I was like, where did you put the note? They changed the sensor, so the sensor was not sending the signal in the correct time because we didn't adjust the sensors. They just placed the sensors out there. And then the robot was receiving the signal too early. So it was just peeking out of the part. Anyway, we spent like 2 hours and a half or more trying changing the program, like breaking our heads. Like, what happened here? Because communication. And they just thought, yeah, but it's a sensor. What could that change your life?
yeah, yeah, yeah.
And it's
It
like, yeah.
it actually reminds me of one of my, yeah, weirdest problems, I would say, was like it was also a pick and place application with the camera detecting the parts, and it worked perfectly. Just sometimes during the day, it didn't work at all. And it was so strange because why does it work for a couple of hours and then
And then so,
suddenly something happens, and we spent really days figuring out what could that mean. Was it an overload of data information, the stack, just, or I don't know, was somebody there and sending different kind of signals or something? And then we realized that above the cell there was a window, and
oh,
at
the sun.
approximately 12, or a couple of minutes after 12, the sun was shining directly in there, so the camera didn't see anything. So the solution was basically just moving the whole cell a few centimeters on the other side, and it worked again perfectly fine. But oh my God, we spent hours figuring out.
Oh yeah,
And
that
then
happened similar with me too. But was worse because I was living in Ireland, so you're testing during the winter time. That if your island is like no sun at all.
yes,
Then the day the client came to do the test was the first sun, like the first sunny day in the year or whatever it
yeah.
was so bright that the machine was picking one part in 10.
Yeah,
And then like we freak out because, guys, we're testing this for 8 months and was never this bad. I mean, sometimes we're missing parts and
yeah,
was okay for the application, but like we're picking 1 in 10 or 12. And then the client, because that was the first time the client saw the machine, so they didn't believe us and we couldn't
yeah,
prove
sure.
otherwise. And
Hmm.
then we're like, I was crying to her. I was like, we sit down, we start talking. And then in between this freaking out, like, was a cloud because this island, it's sunny for a few hours only. So then it was dark again, it was cloudy, and the machine worked. So yeah, was the camera. Was the
Yeah, it's totally strange. I mean, if you know it, it totally makes sense. But usually in a factory, you have the artificial lights. Yeah,
yeah,
you suppose that the lighting is the
it's
same.
okay.
Yeah.
Yeah,
So
and in
interesting
my
that
case, it was not the window was not even on the ceiling. The window was
on
on
the
the
side.
walls, but was
Yeah.
enough to
To
affect because it
okay.
was
Yeah.
dark all the time. And you'd
Mm,
be like, geez. But again, it happened. And and you're gonna say like, oh, you couldn't notice. Like we were like a lot of technicians there, and were like more people, more with more experience than I had back then. Back then I
Why
was like
didn't they see
2 years.
it?
There was people there with 10 years, some with 5 years, and we couldn't figure it out
Yeah.
until like the sun like the sun went out, and then we saw that was the lightning. But
Mm,
again, you like anything can happen. Like it's working.
yes.
It was working fine yesterday. Yeah.
Yeah. Doesn't count.
No.
This actually leads us to our fourth skill, staying calm. And staying calm really shows during commissioning, right? So
Yeah.
especially if you are around, I don't know, 11:45 p.m. in the middle of the night. And then
Yeah.
reality really shows you how much do you really love robotics and what type of engineer you are.
Yeah. Because if you don't like pressure, don't go to commissioning. Just go
Yes.
to another. I don't know which area you don't have pressure. I don't know. Maybe research. Don't know, guys. Like maybe research should be the same, because from troubleshooting to testing, like I haven't seen any area that didn't have any pressure, and you need to work well on the pressure because
Yeah.
sometimes you think you're gonna fix that. It's like yeah, it's already 5. It's I'm gonna just touch up something here and we good to go, and then you realize that touch up was not enough, or you just fucked up something else, or you need more than that touch up, and then when you see it's like 10, 11, and you need to fix that because the client is coming tomorrow,
Yeah.
and that's
It
it.
it also reminds me one of my problem solving issues I spent hours on was yeah, my code didn't work, and I spent hours on searching, and I thought I did everything correctly. And I sat there at the computer and I was looking at the code and debugging, and I didn't find the error. And my supervisor came to me and said, Chitanila, just go home, sleep, go home, and tomorrow morning you will see it. And I was like, no, I mean, I'm looking at the code for hours now. I don't see it. I don't know what's wrong. But then he persuaded me to go back home. And the thing is, really, next day morning, you know what the error was? It was a comma instead of a semicolon. And I was like, Dad, are you kidding me? I didn't see it. It's just
Like we get
the dot.
blind, it's like
Yeah,
it's tired, it's blind,
it's
and
just
so
the
on.
dot over the comma, and it can ruin your code.
But I think it's just we get not maybe blind after we're tired. It's just you think it
Don't.
cannot be that simple, so you
Yes,
look for something
exactly.
more complex in your
Yes.
code, like it's something I wrote wrong, it is the position, it
Yeah.
is you go really far away, and sometimes it's just
It's just
come
the
on,
very simple things. Yeah. Like the
sometimes it's
table.
just select the wrong tool, sometimes you forgot to
Yes.
add the tool, sometimes it's just the position you thought you save with a frame, you save another frame. But yeah, it's just when you're really concentrated, and something that I do, and that's every work I do, is like if I'm working some like a lot of hours in something, I always stop at least one every 2 hours or an hour, depends how intense is the coding, to just go for a walk, see the sun for two
Yeah.
minutes, get a coffee, and come back. Like I used to drink, now I'm working from home, so I try avoid so many coffee, drink so many much coffee. But I used to drink like 5 a day, and that's how we kind of okay. Let's just go for a walk, because the walk to get the coffee and back
Yeah.
will give you a little bit of air, and that would help to fix the problem. Like sometimes could just be that simple. And while you're making the coffee, it was like, oh Jesus, how I didn't think about that. It's just like
Yeah. Yeah. Yeah, there's also the method from programmers. I don't know if you heard it. Explain to the duck. Explain it to the duck. I think it's called like this. So the moment you start explaining to a virtual duck or to somebody else your program, you will figure out the error.
Oh, I
Or
haven't tried that yet. Nice.
yeah, so you and I think the programmers used to say they explained it to a yeah to a little
Okay,
duck.
okay. Yeah, because you need
Um,
to go really explain like in
yeah,
every details. Yeah,
yes,
that makes sense.
exactly. Yeah. Interesting. So I would like to do a rapid fire round. So I will tell you some skills and you answer if it's overrated or underrated for
Okay,
a
let's go.
robotics engineer.
Okay.
So let's do a quick one. Do you think Python is the language, the programming language, is it overrated or underrated? To know.
So like overrated, like it's good to know how we
Yeah, is it
do
is
it.
it well
Uh,
overrated overrated like everybody says you need to know Python, but actually in
oh,
real life you don't need it.
well, actually, right now you don't really need. It's good too, so I would say underrated because the
Underrated.
programming that's coming out, the way they're doing the wizard is the easy programming. Of course, it's better to know because then you can do more with Python. You know,
Yeah,
like when you write the code. But for example, I give it here Universal Robots and ABB that they have the software there, just drag and drop. Like even the
yeah,
Neural here is the same. You have the drag and drop there. You don't need to know even coding. Maybe you need to know a little bit logic,
yeah,
but anyone can go there and maybe watch a video on YouTube and can program. So I wouldn't say is like needed to program a robot. But again, if you have Python, you can do much much more. So I would say underrated because you don't need,
yeah.
but like if you ask me, of course I would do it because I recommend.
Hmm. How about mathematics?
Overrated. You definitely need it. That's If you don't like math, don't even think about automation. Just skip. Like
Hmm.
swear to God, like no, but I don't like make no 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 no. That's forget about it. Like you need it. You need calculations.
In it. So you think it's underrated if you need it?
Oh yeah, underrated. Yeah,
Yeah,
sorry. Yeah, you
underrated.
really need
Yeah.
it. Yeah.
Mhm. How about soft skills?
Like talking to people.
Talking to
Oh,
people, yeah.
I think overrated because you just need to
Overrated.
talk with the.
With the robot.
I didn't have it until I started posting videos, so
Yeah. What
I didn't.
about patience?
Underrated. Well, kind of need to be patient because you need to try and try and try and try and try again. And
Until
tomorrow you need
it
to
works.
start from the beginning because
Yeah.
whatever you did it just didn't work. So you try again.
What
Is that
about
it's not gonna work? What I always say, it won't work first time, and if it does, you did something wrong. So double check.
yeah. We had that the last time. Yes,
Yeah.
exactly. Yeah. What about artificial intelligence?
Hmm. Right now, Jesus, overrated. Because
Right.
the
We're not
thing
there yet.
is, I don't think so. Like I know it's great the way we're going, but if you go like in the industry, and I say right now, if you walk in any manufacturing, at least the one I had access in Ireland, I worked with, we couldn't log in on the robot remotely.
Yeah.
That's how their mentality, the
Yeah.
manufacturing is about connecting with the cloud or with the internet. When they see the AI, so like we are not even on the 4.0 whatever the technology was with internet, like like it. And the research part is amazing the way that they're doing with AI and physical AI. And I'm not saying that's wrong. It's just like what we see launching now, that's not what is an industry and might be just like a really small part of the whole portion that you're gonna use that right now. So I say overrated because I went to the companies, like I seen that, and you can say it would gonna save their life. lives. They're gonna, reduce the costs. They're gonna help them predict maintenance and whatever you like. You can do all the speech. They're not gonna do it. And I know that because I worked in manufacturing
Yeah.
and I could not convince anyone to connect the robots to the cloud so we could automatically do the backups without stopping production or without need to go to the factory and back up 50 robots and I don't know, more than 400 machines.
Yeah.
We have to do one by hand. So we have to get your USB stick and go in the 50 robots one by one and stop and get the backup because they couldn't. Of course, some of the robots wouldn't even connect to the cloud. That's fine. It's really old, like 20 years. But like 90% that we could just log in. And I'm saying not the internet like cloud.
Yeah.
Sorry,
Intranet.
not cloud. Is the intranet like we would have access. The IT only and myself, we would have access to that to get a backup because like Cook and ABB, you could access and just download the backup like this. You don't need even stop the robot when you connect to that. And you can even program, like the IT guy was like, no, you can program to do it overnight so it wouldn't affect anyone. The answer was no, because if someone hacked their system, the robot would be affected. And right now, like I would say a few years ago, I saw already there are these brands working in software that you could connect your robot and you could see everything on your phone, like for when was the last maintenance, when you need to, change a belt, whatever, the oil, the fan, they would report everything. Even you could see like no, you can see now, like when the robot is running, um, the energy consumption, so you can, optimize the cycle time, not for time only, but also to, reduce the consumer of electricity, because sometimes it was like you don't need to go that fast, so you could. And I haven't seen that. Like we're going so fast. For me, like we're going too fast, and like why manufacturing, yeah, the reality is different. So for me, as experience on that is overrated because of that. But like it's great. I'm not saying it's bad. It's just like if you work in manufacturing, that's not gonna you're gonna see. Or if you're studying right now, expecting to see that in manufacturing, it's not. Sorry, break your heart.
So here we go again with patience and communication skills, right? What about perfectionism? Do you think it's overrated or underrated?
Overrated. You don't need to be perfect. Yeah, because you're not going to be perfect. Because again, you can't, like, whatever you write, the robots will work. Yeah. You just like you're gonna just waste your time trying to be the best, like do the best program. Like what? Because I would say that by experience, because I used to think like this. I was like, yeah, if I can get the robot to perform as fast as could go and like perform well, like the customer will love it. So I was programming this machine, was the pick and place with the camera there that we just talked. So I don't remember how many parts per minute, but like I got, I think almost 60 or something like that. 60 or 50 something parts per minute, when it was speeding up and it was not like missing one part every 2-3 minutes. So it was great. It was like I spent probably 2 weeks to get to that speed because we were already fine. But it was like, yeah, we can increase the speed, we can pick more parts, because I was trying to be perfect. Yeah. Then the client come around. That was after the problem with the camera, when he saw it working. He came around and was like, well, our production only can support 42 parts a minute. Yeah. Or something like that. So the machine was doing probably almost 15 parts more that they could handle. So it's like, yeah, nah, turn it down. They don't need it. Yeah. No, we don't need that. So like I wasted, well, not wasted, it was because I learned something in between, but for me, it was like, I just wasted 2 weeks of my life to improve this, and it was not necessary.
Yeah.
So
Yeah.
perfection is not like, I think you need to do the best you can for what the client needs or the production needs. Or otherwise, your robot is gonna move in, of 30 seconds, and the box is coming every 2 minutes. So why? Why?
Yeah. Yeah.
It's like,
Yeah. In project management, you call that the minimum viable product, right? The minimum it should be able to do is just enough.
yeah. But back then, I was just
Yeah.
learning, and
I mean, yeah. It's good to be motivated.
yeah, yeah. And I was like, yeah, I can. Like, in my mind, like, yeah, the robot can do more. Let's do more,
Let's show
and
them.
yeah, let's just do it, because they never said to us that limitation
Yeah.
was because of their machine. They just what they want, and it's like, yeah, if you can show more, better.
Yeah.
And the project manager said, like, yeah, if you can do more, we do more. Let's go. Because they asked, like, Vanessa, do you think we can do more than 42? It's like, I think so. Let me try. And then we were increasing the speed every single day. It's like, yeah, it's working, it's working, it's working. So when the customer come around, it was like, wow, that's so many parts. We cannot handle that.
But very good example. Yeah, yeah. To talk to the prior, or to look at the prior cell and the next and the upcoming, what they can handle. Yeah,
Yeah,
it's very
few
important to
lessons
get the
you learn all the
interfaces.
way. Yeah, ask
Yes,
question, communication.
exactly. So what do you think? Which is the skill universities spend too little time teaching?
Well, I would say, well, as I said, I didn't do engineering, sorry, robotics engineering, so I cannot say for sure. Maybe you can answer that, if correct if I'm wrong. I would say the troubleshooting part,
Mm.
because at least when I learn in manufacturing, and when programming robots, all the trainings, I got training in 7 brands apart from the ones I got here that I learned myself. There was nothing on the trainings covering troubleshooting specifically. What I
Mm.
learned was when I was working in that when the system integrator, that we have to do as part of our job. So we are learning doing it. But I think that explanation, like what would be the steps while you could face, I don't know if you have that, I have in robotics, but I think is, overrated right now. You need to have more.
Mm.
Sorry,
Yeah.
underrated.
Underrated. Yeah.
Underrated, sorry.
Yeah.
Because I can see that when I go on site to troubleshoot a robot, and I'm doing a few steps, and then everybody comes along, it's like, how long is that gonna take? It's like, well, I need to see, like, it's a lot to check. You just not the code itself. You have to spend time to understand the logic, to understand why it's doing this before you starting changing the program.
Yeah.
And I think it's one of that, because they just learn. It's like, yeah, you need to learn this, you need to learn ROS. It's, yeah, you're gonna do that. But yeah, what's gonna happen when you face something that was already programmed?
Mm.
You
I
know,
actually agree. I actually agree that we are too much focused on the right solution rather than what else could be go wrong. And for this, it actually needs a mathematical understanding of the state spaces an automation cell has. So if you, for example, have a binary sensor, how many state spaces does this sensor have? One sensor only has two states. But if you add one more sensor or a third sensor or a fifth sensor, and you have the robot, which has, I don't know, 7 possible positions, then your state spaces increase exponentially. So actually, you need to focus on all those state spaces in your program and say, if there's combination of robot position and sensor state is this, then something happens. And this is actually a very complex task, but usually you just program, if the sensor is like this in the correct way, then it should move to that position. But you never focus on the other state spaces which shouldn't.
Yeah.
Yeah.
And
Be
other
there.
thing, so sorry, I cut you.
No, it's okay.
Other thing that apart from that, something I learned, because when I was learning programming there and that system integrator, we have trained in house, and we're trained by the supervisors that were like he had like probably 15 or 20 years experience. So he was explaining how the steps should go. So it's great. But when I start get trained outside in other brands, when I opened my business and got out, I noticed that one specific step that for us was really important, like you have to do this in the beginning, was just explain in the advanced training when you're learning the, like to write the code in Python, similar languages, Parallel, Rapid, when you're learning how to write that, that's when they explain this step. And it was like, that should be the first thing, because when we're learning that is to sit down and write the steps of your program, do the graphic there, as you said.
Yeah.
All the areas you need to cover here and there, and do I forgot the word now. It's like a map, a graphic, a map. Okay, the robot need to pick, and then after pick, we go to place, or I need to go somewhere else.
Yeah.
And then if you fail the place, you should go to, what should do.
Yeah.
You should write that everything. So we have to do everything kind of there. It's like, yeah, we have to do, and I still doing this. Like when I want to write, like, yeah, I write it down. And even send that documentation, but like, it's really like the before I open my laptop to write the program. Yeah. And like we used to do this a lot, but I thought it was common, again, because I learn with the right person, but not everyone does that. And then I went to trainings, for example, Universal Robots is great at training, and I am a trainer for them. But you just learn that and how to do that on the advanced training. Mm-hmm. You don't learn that before. And you'll be like, well, but that's important, that you should learn before you write the code. Because sometimes it's just like, oh shit, I forgot to open the gripper before I go down. Yeah, because when you wrote the code, the gripper was open, but like when you run, you might not go. Yeah. And you just realize that, well, when you're running, you're going to learn, of course. But if you think better, that should be teaching them on the training, on the basics. Like, yeah, before you write the program, you need to understand the logic that your robot's going to follow. Like it's gonna just pick, it's gonna just place. You have more picking areas. You need to check the sensor, which sensor you have to consider, like doing that structure. And again, I think it for Universal Robot and Kuka, and I think others, I don't remember even seeing it. Like I haven't remember seeing that in Fanuc and Kawasaki, and haven't seen that. I just only saw that right now, I think in Kuka and Universal Robots. And it was like, yeah, but that's the advanced training. Not everyone gets here. Like, some people just needed the training to write some, even though if a basic pick and place, that information, that documentation, not just to document that, but to understand you're covering everything, so that the time to program it will be just less. Because when you have the picture, like you need to cover. Yeah. Like why you have 5 sensors on the conveyor, you're just checking one. There is a reason to 5 sensors there. Yes, exactly. Yeah. People don't spend money for 5 sensors because it's great. And I remember like one of my projects, when I saw, because they did a simulation, when I saw the simulations, like, yeah, a lot of things that's not gonna work. The manager didn't like that. I was like, well, I'm gonna be honest, like, just look there. I just zoom in. I was like, yeah, you see the gripper open like this and going through the conveyor. That's what's gonna happen in real life. But instead of going through and going out and up, you're gonna get it into the conveyor and grab the conveyor and going up. with everything. Because the payload of that robot is like I think 200 kilos. So he has the power to go and grab the. It's like Novin is like, yeah, look at that. Like the gripper open on the conveyor, like it will pass through the conveyor and up. So thank God I spot that, because in 7 or 8 months they were building the machine, they couldn't spot, because they have like bars on the conveyors on the both sides. So it fit perfect. The gripper closed, would fit on the conveyor, but when you open, there
Open,
was no
yeah.
space to open. It's like, yeah, oh, but it worked fine on the simulations. Just spot that. That's not gonna happen. Uh, the singularities on the robots, like the robot doesn't do that movement. You cannot go that way. Your robot doesn't have 6 axes, you have 4, so you need to go that way. They were so mad. I was like, I was spotting things on the simulation, and they was like, yeah, but that it worked. It's like,
But
no, guys.
that's also a classic, right? Simulation works, and they think in real life, but
And then
simulation.
they didn't have a camera. I can explain a lot to the projects for NDA, but they're picking apart, like I can say the part was a pallet coming in with parts, but like was a stack, the parts, like 2 pallets with parts in it. So the robot needs to remove the products, the pallet, and the second pallets.
Mhm.
But the parts were not stacked by a robot, it was by a human a few years ago. They were just they stacked the things. So there was a problem because it was not perfect aligned. So for that, what you should add? A camera. Jesus, that basic. Do I need to say to that to you? I saw the problem. Like, yeah, you need a camera here. There is no sensor right now that can identify the part, the middle of the part, if they're beside each other. They didn't listen to me. They complained I was wrong. I need to make work what they have. Like we try our best, but I said, but again, the product was not a box. Just keep in mind, it was really heavy product. It's not
Yeah,
something that you can misplace. You have to pick properly, or your doors would drop. And it would be a really accident because it was a heavy product. And
yeah.
I explained like, no, you need a camera, a sensor. They changed so many sensors. I think we tried 4 or 5, and one was I forgot I forgot the word for now for the sensor that's is like a beacon, like the bat that it would send the signal and receive. I forgot the word for now, but anyway, we tried a lot of sensors and didn't work. We spent like 4 weeks trying, and I explained, guys, we need a camera. Anyway, they didn't want to go ahead with me to finish the project because I didn't know what they were saying, or I didn't agree what I didn't make work. That was the reason, because they didn't want to listen to me. I was like,
Yeah.
fine, that's okay. You keep testing, like. Then a year passed by, and I met someone of that project in a situation, and I asked, like, yeah, like, please let me know how it went, like, it did work in the end. And then the guy said they spent, after that time I was there, I think we met a year and a half later. He said they spent around 10 to 12 months testing, trying to
Oh,
make work the sensor that I said on day one that would not work. And I was honest. They tried for almost a year to make work every single day, every single day. Then in the end, they had the camera that I said.
and it worked.
And then I look at him and said, "Well, I'm glad that you finally try my option then and it worked."
Mm,
It's just like, if you don't spot all the, like, they just saw as a pick and place application, we add the sensors, you go for it. No, you need to analyze, write it down, like as you said there, all the areas of your robot, not just where you're going to place the
yeah.
robot and where you're going to place the conveyor, but like how the product is coming in, where is going to be the sensors to identify that product. And like, thank God now I have more. Again, I'm not saying I'm know everything, but I have an eye. Like now I can identify, because as I do this every day, to write down the steps and everything, is get to a point when you start doing that from the beginning. So when you see a project, you can in your mind doing the steps in your mind. It's like, yeah, the robot needs to go that way. You need to check that sensor. You need to cover this area. You already start visualizing that in your mind before you write it down. That's
Yeah.
how you get, better in your job.
Why do you think they didn't listen to you?
Because I think, because, well, back then I looked young. I don't look the age I am. Well, back then I didn't. I'm a woman, and I was a contractor, and they want someone, and someone from their company said we would work, and I didn't. And they want to someone to agree with them, and I didn't. I was honest, and I'm still honest. By now I lost a few projects because of this,
Yeah, you told
because my honesty, because I would say it's not gonna work that way. Are you gonna take more than 2 weeks? The client was like, yeah, but somebody else said you can do in a week. Like, yeah, happy you go.
Okay.
3 weeks passed by, and they still working something that I said it would take 2 weeks and more. But some clients, they don't want a different opinion. They want someone to agree with them and make their option work, because that's what they sold to the client, if you know what I mean.
Yeah,
Like, they sold to the client,
or internally to their boss, yeah, and they don't want to lose their face.
Because, like, can imagine, like, we're designed, because when I got to when I started the project, because I was a contractor, they were already work on that project for probably 8 months, because they were like building the stuff. I got there when their robot arrived, but like they have all the conveyors, everything already set. They already had the design, they already have the PLC, everything was already to be finalized. It was just to get in, program the robot, and connect everything. So I was the only one that watched the simulation properly and start making questions. If I hadn't seen the simulation and it wasn't me to program that robot, they would crash and they would break the conveyor on the first try. Because I was like, they couldn't spot that the conveyor was not in their mind. The way I proved that the gripper will break through the conveyor, like get into the bars, I moved the robot above the conveyor a little bit, like this size above, and then I opened the gripper and I was like, just watch what would happen if I go lower there.
Yeah.
Then they call somebody and have to cut the bars and do something else. And I was like, but again, how I would prove to them that the camera would work if we didn't have a camera?
Yeah.
If the sensor wouldn't work, if we haven't tried the sensor, I just knew, it was like, there is no sensor that could do that, because I've done a lot of projects with sensors, and there are some limitations on sensors. Probably right now you probably have better sensors, but again, this was 4 years ago, and what we had back then, and again, if you listen to this, don't take my word that is true, because again, we have a lot of technologies, and with AI we might have a better sensor right now, but back then it didn't. And I knew there was no sensors, and I said there is no sensor, but someone for another position, high, of course, I was just a contractor, this guy was somebody else a little bit higher, close to the manager, and he said, no, it's possible, we can make work. She doesn't know what she's saying. I was like, fine, thank you very much. Here's the program. I did my best. It was like, yeah, unfortunately, we try, like, and I try for 4 weeks. And I said, like, unfortunately, there is no way to predict with what we have now how it's gonna pick, because the sensor cannot identify where is the part. It just can identify if the part is there or not, but it cannot see it where it is. And like, because it was not a robot that packed the product, the product was never aligned. Like, you would find one pallet aligned in 20. So they didn't want, like, they just end my contract. I was like, happy I go. I was like, nothing I can do. But like, I was so delighted that a year and a half later, And they tried for a year because that guy, and I presume that guy said would work. But I don't know how the client even allowed them to keep
To
testing
work
for a
that
year.
long.
Yeah, because
That,
I
yeah.
like I never seen,
Interesting.
because
Yeah.
we already, like, we went on site. That machine was already on site.
Yeah.
After that, like, what I was trying, the 4 weeks was on site with the client, so it was already production. But again, like, I didn't lie, and I saw that a year and a half later, if they had listened to me in the beginning, or even tried the camera, we might have that done in that 4 weeks we were there testing.
Yeah.
But it is, some people, they just want someone to agree with them and make their idea work.
Yeah.
But in my point of view, and I have a friend in Brazil that he also, a consultant, a contractor, and he says, like, Vanessa, some clients, they just don't want to listen. They pay to us as a specialist to advise and work. My case, I'm not just advise, I also program the robot, but I program in the best way. So I would advise the best way that I'm gonna program that. But some clients, they don't listen, and that's okay. Sometime they will understand that we were right. Unfortunately, that happened a year and a half later. But
Yeah.
again,
Yeah. Interesting. Very, very interesting story. What one final question to wrap it up. If you could give one piece of advice to a 20-year-old student studying engineering or robotics or mechanical engineering, what would it be?
well, I said that a few weeks
What?
ago in an event in Italy. Don't be afraid to make mistakes. I don't know if we
Yeah.
said that before here,
Yeah, we
but
said.
yeah, don't be afraid to make mistakes, because that's the way we learn.
Yeah.
And when I started, I was really afraid to making mistakes, and then I realized in automation and mechatronics and anything related to robotics that you try and build something new, 99% of the time you will not have the answer straight away. You need to try and try and try again. So if you're afraid to make mistakes, scary that you're gonna, getting a error or anything, that will hold you back so much. Like, it took me months to realize that. I would say, don't be afraid, believe in yourself, and is not that complex as
Yeah.
everybody else says. Like,
I love
you
that.
can, yeah, you can go easy, or you, of course, if you want to go deeper and get more complex stuff, of course you can. But doesn't mean all the areas in robotics, in automation, is that complex. Because
Yeah.
I heard that a lot. It's like, oh yeah, you have to learn. It's like, no, like, for example, I never learned ROS.
Yeah.
I'm starting now, but in 7, almost 8 years of my career, I haven't learned ROS, and I haven't used ROS. So, like, oh,
Me
do I need?
neither. Me
Yeah,
neither.
because
Yeah.
people was like, oh, do I need to learn this? And I was like, no, I learned Python halfway through. Like, I was already working in automation when I started learning Python.
Yeah.
I had C++ that helped me before. But again, if you're gonna think I need to learn everything at once, then starting in robotics. That's not the
Yeah.
way. You don't. It depends where you want to go, but like when you specialize, that's going to take a while there. You need to understand, but it's not that complex. You need to understand not all the fields, not all the areas inside robotics are that complex.
Yeah. I love that. I also learned that to not be afraid to say I don't know it. I don't know it yet, but I'm willing to figure it out, and maybe somebody else can help to think it through. Because yeah, you don't need to know everything, but you need to
Yes,
be open to learn it and to figure out the solution. Yeah, because
definitely.
there is
Yeah.
always a solution to a problem. Yeah.
It's just open, like to understand you don't know, and that is okay to say I don't know, I'm here to learn, because somebody else might know the answer. You can learn today, and then tomorrow you can be the person who's teaching somebody else. So
Exactly. Yeah. Well, thank you very much. It was so nice to talk to you again.
it was great to Thank you,
Yeah, maybe,
everyone. Listen.
yeah, maybe if you have some memories on projects or problems you did solve, and some skill set you think are important, we would be happy to see it in the comments.
Yeah, or if you have any questions, which one you think we didn't comment here, please
Feel
let us
free to
know, and we
add them.
can comment in the next one.
Yes, exactly. Thank you for listening, and see you next time. Bye.